Okay, so good day class. So our lesson for today is about LU decomposition. So a motivation for an LU decomposition is based on the observation that the system of equations involving triangular coefficient matrices are easier to deal with. So recall, we have two types of triangular matrices now. Ito yung upper triangular matrix and lower triangular matrix. So indeed, the whole point of Gaussian elimination is to replace yung coefficient matrix with one that is triangular. So the LU decomposition is another approach designed to exploit yung triangular systems. So matrices can be decomposed or factored into product of two other matrices in many number of ways. No? So one way to decompose A is we can let A to be equivalent to L times U. So where L here is the lower triangular and U is the upper triangular matrices. Specifying the diagonal elements of either L or U makes factoring unique. So we have here three existing methods. So Doolittle, Kraut, and Koleski. So we assume that we can write A is equals to L times U. So our aim here is to find L and U. And once we have done, so we have found an LU decomposition of the coefficient matrix A. So an LU decomposition of the matrix A is a product of the lower triangular matrix and an upper triangular matrix that's equal to this A. No? So of course, the multiplication process follows the rules of linear algebra. So yung three factorization methods, una yung Kraut method, wherein we expect yung diagonal of the upper triangular matrix are all equal to 1. So U sub II is equals to 1. So we expect that U11, U22, U33 are all equal to 1. No? Next, Doolittle method. So for this case, yung diagonal ng lower triangular matrix natin are all equal to 1. So for that case, L sub II is equals to 1. Now for Koleski method, so yung diagonal ng U is equals to the diagonal of L. For this case, yung U II is equivalent to L sub II. So expect here that U11 is equivalent to L11, U22 is equals to L22, and so on. No? So for the Doolittle, so for example, so for this case, yung diagonal ng L natin are all equal to 1. So ito yung mga L11, L22, L33, L44, no? And yung X natin dito can be any real number. Next, for the Kraut, for this case, yung diagonal ng upper triangular matrix natin are all equal to 1. So, when itong U11, U22, U33, U44, no? And again, X here can be any real number. Now, for the Koleski, so yung diagonal elements natin are equal. So, for this case, yung entries dito equal to this entry for L and U, no? And of course, X here can be any real number. So for example, using the Kraut method, so given this coefficient matrix A, so we need to find the equivalent decomposition of this coefficient matrix A as LU, no? So L here is equivalent to the following entries, and similarly for U, we have here these entries. So multiplying out LU and setting the answer is equal to A, this will give us this matrix. So simply multiply this matrix L to this matrix U and equate it to this A. This will give us this equation, no? In the form of a matrix. So obviously from this, so we can determine the value of L11 as 1, okay? And L21 as 3, L31 as 2, no? Now for the second column, okay, so we can generate this equations. So L11 U12 is equivalent to 2. And since we already have the value of L11, which is equivalent to 1, so we expect that U12 is equivalent to 2. So substitute lang natin, no? Then for this entry, equated to this 8, okay? Then we already have the value of U12 as well as L21, which is 3. Okay, we can determine here the unknown, which is L22. Okay, so this gives us a value of 2. And for this entry, equated to this 6, okay, this will give us the value of L32, which is equivalent to 2. Now for the third column, it's the same process, equated to the following values. This will give us the following values. So for U13, U23, and L33. So to summarize yung answers natin for L and U, okay, equated to this coefficient matrix A. Now using the another method, which is the do little, okay. So for this case, so again, we can let a variable this given coefficient matrix A to equivalent to LU. So this time, yung entries ng L natin is yung entries natin sa diagonal will be all, or all equal to 1, no? And all other entries can be any real number, okay? And for you, this will be the entries. So multiplying out L and U and setting the answers to A, this will give us this matrix form, no? So from this matrix form, we can determine here the value of U11, okay, which represent this value, okay. Then U12 as 2, U13 as 4, no? Then for the second row, L21, U11 is equivalent to 3. Since we already have the value of U11, which is 1, this will give us the value of L21, which is equivalent to 3. Then for this entry, so equated to this value 8, okay. So L21 is equivalent to 3, U12 is 2, okay. And the only unknown here would be U22. So equated to this 8. So just isolate the variable U22, just give us value of 2. And this one equated to, I think this one pala, so second row, third column, equated this 14, okay. So already have the value of L21, U13, then 4. So just isolate the unknown U23. This will give us a value of U3 as 2. No? And lastly, using the same process for the entries in the third row, created the following entries. We can determine here L31, L32, and U33. Okay. So we have shown that A, the given coefficient matrix A is equivalent to this L, then this U. No. So which is actually the LU decomposition of the given matrix coefficient matrix A. Okay, so using MATLAB, we can enter this algorithm for the crowd LU decomposition of the coefficient matrix A. Then, of course, we need to enter the entries, okay, in the coefficient matrix A. Then apply this uh, crowd LU command, no, in the command window. So, of course, to enter this function, you need to click the home, then highlight or click this new for the drop down menu, then just select this function. So this will be the default. Okay. For the editor and function, just copy paste this code to this editor. Okay, we can create a function for the crowd LU decomposition. Okay. Then in command window, just enter the given coefficient matrix A, then apply this command. No? So L comma U enclosed by a square bracket equals to crowd LU of the A. No? So this will give us the coefficient matrix L and U. No? Now using the built-in LU function in MATLAB, we can actually evaluate yung LU decomposition ng coefficient matrix A using this LU command. So LU, L comma U, then equals to LU of the A. This will give us yung results for L and U. So if you try to check, this L is not actually a triangular matrix. No? Now, using the LU decomposition to solve the system of equation, so once a matrix has been decomposed into a lower and upper triangular matrix, it's possible to obtain a solution to AX equals to B in the direct way. So the procedure can be summarized as follows. So given A, and we can determine L and U, so that we can A is equals to LU, then of course, given linear system is in this form, AX equals to B, where X here is our variable, and A is the coefficient matrix A, and B is the column vector of constant. So hence, since A is equals to LU, we can replace this A by LU, then times X equals to B. Then we can let the variable D to represent this UX, so that we can rewrite this as this form, no? LD equals to B. Then we can solve this triangular system for D. So after solving for D, we can now go back to this letting of variables. D is equals to UX. Okay. So we already have the value for D, and U was obtained from the first part. And of course, X here represent our variable. Then just solve for the value of X now. So the benefit of this approach is that we only ever need to solve the triangular system. So the cost is that we have to solve two of them. So consider the following system of equation. Okay. So X natin dito is obviously x1, x2, x3, no? And the coefficient matrix A is 1, 3, 2, 2, 4, 3, 3, 4, 7. And the column vector of constant 15, 22, and 39, no? So yeah. So yung first step is to decompose yung A natin matrix into LU. This will yield as to this, okay, equation matrix form using the function of Kraut. And for the decomposition, so yung form natin initially is AX equals to B, no? And we actually decompose this A as the L times U, and we let the variable D to represent yung product ng UX. Okay, that's why we can rewrite this matrix form as this form, no? L times D equals to B. Then going back to the letting of variables UX, or letting D is equals to UX, we can solve for the value of uh, X, which represent now the solution for the given system of linear equation. So after obtaining the L and U, so the second step here is to find the vector D. So recall this procedure. So D here is UX, no? So that the given system of linear equation can be expressed in this form: L d equals to B. So we already have the value of L from the first part. Okay, this is the L value, and D here can be expressed as D1, D2, D3. If we're given as uh, three equations, again also. So equals to, the B here is the column vector of constant. Okay, so from here, we can determine here the value of D1, D2, and D3 by considering this three equations. No? So obviously D1 is 15. No? And using, by solving this two equations simultaneously, we can, since we already have the value of D1, we can determine here the value of D2 as well as the D3. So this gives us a value of 4 and 4, no, positive. So the matrix D here turns out to be 15, 4, 4, no? Then the third step here is to find the solution, vector X. So this is the last step. So we have here this form, matrix form U times X equals to D. So the D here was obtained from the first, the second step. Okay, of course our X here is our variable from the given x1, x2, x3. And the U here is the upper triangular matrix, which is obtained from the first step. No? So ito yung 11132.5. So from this matrix form, we can determine here the value of the x3. It turns out to be equal to 4, x2 is equals to 2. By substituting this x3 equals 4 to this equation, we can determine x2. And of course, x1 can be obtained by considering the two values x2 and x3. So this will give us now the solution set for the given system of linear equation x as 1, 2, 4. So using MATLAB, so of course we need to declare first what is A, what is B, and using the CROUT-LU command function, uh, so L comma U equals CROUT-LU of D, then solve initially for the value of D, so which is equivalent to L uh, divided by B, and to solve for the value of X, X equals to U over D. So this gives us the following values. No? So this is the LU, this is given A and B, and this is the value of D1, D2, D3. And of course, X here represent yung X1, X2, and X3. Now, using the LU function built in MATLAB, so similar from the previous slide. So of course, we need to declare as A, B using this command LU. So D is equals to L over B, X equals to U over D. So this will give us the following values ng D1, D2, D3. And of course, we have the same value for X since we're considering here the same system of linear equation. So X1 is 1, X2 is 2, X3 is 4. So this ends of our presentation. Thank you for listening.